Afternoon, audio good? Just a quick show of hands before we get started. How comfortable is everyone with Terraform? May not be everyone's tool of choice, just show of hands. Cool. And so another quick question before we get into it. When was the last time, and answer this kind of honestly to yourself, when was the last time you actually looked at your application's monitoring? So raise your hand within a week, within a day, outside the context of being paged. Nice, nice, I love it. All right, so my name is John, this is Alec. We're gonna be speaking on Chegg's approach to scaling application observability today. A little bit about the agenda. We're gonna go over who we are, the challenges that we face, the opportunities that we saw, and the solutions that we came up with. Like I said, my name is Jonathan. I've been with Chegg since 2016, have over 15 years of backend engineering experience. I'm a contributor to Chegg's IAC for Aurora, DynamoDB, Chaos Engineering, and many more templates. I'm a lover of software, cloud engineering, architecture. Plain and simple, I like to solve problems.
Hello. I'm Alec. I'm a senior software engineer at Chegg. Some facts about me: I used to be a mechanical engineer. I don't like cars though, so this partially explains why I'm not a mechanical engineer anymore. I've been a software engineer at Chegg since 2019. I work on schema governance with GraphQL, and also I'm part of the new Relic working group. I really like working with great tools. Some of them are access code tools. Some examples are like Terraform or Plant UML, which you'll see a few diagrams in this presentation.
So a little bit about what Chegg does. We're a direct-to-student learning platform. We help students learn and understand their materials in various ways. So Chegg provides academic services, Chegg Study, Chegg Writing, Chegg Math Solver, skills, and required materials, which you all know as textbooks. Who we are. Chegg is a global company serving 190 companies. Speaking a little bit about the scale, we have 6.6 Chegg service subscribers, 19 million platform unique users in the average month. We have a couple of awards through 2021, 2022. So we've been around a while. We're pretty good at what we do.
So where we were, this is a relatively, well, not too long ago, snapshot of our architecture. As JB mentioned, we're comprised of several products that offer several services to students. Some examples are like math or writing. And back then, most of our applications, or most of our products were on their own independent application stacks. Oh, can I borrow the, yeah. So what this meant was that there were a lot of independent solutions to common problems. There's also a lot of duplicate code everywhere. So here's a more recent architecture picture of Chegg. We recently unified our application stack with Apollo Federation. This removed some of the silos that we had in our product applications. And this was great because we have increased interactions between stacks, and there was more communication, more cooperation, there's more code reuse, and less duplicate code as well. This was great until we ran into our first production incident on the new application stack. What we realized was that in this new architecture, all these services were bringing their own independent solutions to monitoring as well. So I try to illustrate all the custom shapes or New Relic monitoring. One thing that we realized right away was that it was really hard to find the service owner. Often that knowledge was siloed and contextual. Another issue that we ran into was that as we were debugging this issue, we were jumping into different application logs and they weren't standardized. And then lastly, and probably the biggest issue, our alerting at the client, which initially alerted us to the issue, when we traced it back to the backend services, or the backend service alert did not trip. So we had a misalignment on what we were measuring. So to summarize, the challenges that we face is standardization. We have this new architecture where a lot of our applications are now in this single environment, and all the differences are really shown quite clearly. And then secondly, we had to standardize, and we had to do it fast. We had to scale it out to all the new applications that were brought up to support this new architecture, and also to allow the services migrating into the new architecture to standardize as well.
So how did we accomplish this at scale? We had a growing number of services, a need to standardize, and a need to increase the reliability of our services across varying teams. So what did we build? We built a Terraform module, and we support 5 application frameworks which are deployed through Terraform as a service module, and we built the module with the common entities that attaches to the service module itself. So now everyone gets these benefits for free. The benefits that we have included are standard browsing alerting, standard application alerting, and custom alert conditions. All alerts are fed to an alert quality management dashboard, so you now have one central place to look at everything across the board.
So peeking a little bit under the hood, what we provided was a standardized API for consumers to set up their alerting. And by requiring certain inputs, we can enforce best practices. So for example, we required an on-call parameter. Our on-call solution is VictorOps. So near the bottom of the screen, we require a VictorOps channel to be provided when you consume the module. Secondly, we can also promote good practices with optional parameters. One example is the runbook URL. So our issue earlier of not being able to find the service owner, we can promote this by allowing teams to add a runbook URL to the alerts that they set up. So it's really easy for someone when they're debugging to find out who the service owner is and what to do. And then lastly, this module is highly customizable. One example, near the top, we have a local variable that sets up custom configuration for the alert condition on error percentage. So we've customized the thresholds for warning and critical. And then we also allow custom NRQL conditions as well. So outside of the base alerts that we provide, any team that wishes can add additional custom conditions. So one level further down, these are the conditions that come out of the box for free with 0 configuration. They're based on the golden signals, the first one being latency. So we measure latency through AppDex, and we provide this condition for both browser and APM. We also measure error, and we'll alert on errors as well. This is also available for both browser and APM. And then throughput. This is where we had a little bit of issues. So we found that our traffic pattern didn't lend itself to New Relic's baseline alerting. What it was our traffic was too spiky, and we were often getting false alarms. So we had to default to a static threshold. This isn't ideal, and we're talking with our New Relic partners to improve this in the near future. And then you might notice that saturation isn't included in here. That's because we use AWS ECS, so it's a hosted solution, and then we just scale out whenever we had like CPU or memory saturation. And then one of the benefits of having this core module that everyone consumes is we can do things inside the module, like feed all the alert data into AQM, which is Alert Quality Management, and review our alerting data. So if we look back, this is where we started when we had that incident. Our previous problems were it was hard to find the service owners. We had non-standard logs, and our alerts weren't aligned at each level. So after the module, we have standardized our alerting a lot across the application stack. We've addressed the issue of finding service owners. There are other issues like the non-standard logs and alerts not being aligned that we wish to address soon, but this module has set up like a foundation for us to build upon our automation work.
So the next step's picking up where Alec left off. We have a lot of gaps to fill, and we're going to do this like any good engineering group. We formed a working group. So what the working group, appropriately titled New Relic Center of Excellence, our priorities are standardization, automation, and communication. So standardization, we want to create a consistent mechanism for all teams across services to have consistent naming, consistent rules, consistent setup out of the box. Automation next plays into that with Terraform. Given our service structure through IAC, since every application framework stems from it, we only have to make the change in one place now. And communication, we want to create a consistent dialogue between teams about what health actually is. Instead of up or down, is your service performant? Is it performing like it did on the last deployment? Next slide. So speaking on standardization, just recapping a little bit, we set up service level management. So our group focused on what is health? What are we looking at? What are we going after? Application naming as it relates to New Relic. We had a very inconsistent naming scheme across services. Some were just the purpose of the actual service as a name. Others were like environment, some attribute, and then the service name. So we want to squash all that. We want to create consistent schemes so it's available to everyone and it's understandable by everyone at the same time. Alerts that each application should have out of the box. So now we approach it with a zero config mean. And unified definition of health. So our goal is to take the services that we have, create consistent baselines for them, and then have application teams revisit them on a daily basis. Not a daily basis, but a sprintly basis. You know, from the last deploy, did you reach your objective, your SLO? Automation, Chegg already uses Terraform. We've extended our use of Terraform to an application monitoring infrastructure now. So not only can we deploy services with Terraform and scale them out horizontally, we can actually do the same thing with our monitoring infrastructure as well. So we'll add in these consistent alerts, we'll add in more, we'll begin to add in, we're actually encouraging engineers to go in and add their own specific to their service because right now we only have kind of base level alerting. You don't have specific alerting that's really attached to what it is you're doing. In communication for those services that are not enabled, so we have AWS accounts, but our AWS accounts are broken out into logical application groups. So there are many AWS accounts per our Chegg engineering org. So for those that are not in IAC, because this is legacy behavior, we created a guide on how you can create your SLIs and SLOs in these same alerts to put you on the same scale until you can move your team to an IAC infrastructure. And lastly, actively, we're going to pursue engineers and encourage them to revisit your health on a more active basis. So we don't want you going in when you're only paged, we want you looking in every sprint. These are some of the basic alerts that Alex just went over. We're just going to put them at a high level. Apdex, error percentage, and throughput are all APM. And in-user Apdex and page views with JS errors are browser alerting. APM is enabled by default. You're encouraged to use browsing if your service supplies it. Engineers are encouraged, of course, to add more to it. So this doesn't include like async workloads and things like that. Next steps. Automating threshold tuning. So we have some very high-level baselines. You're encouraged as an application owner to go in and say, hey, my application was performing at this level. Let me fine-tune it and redeploy it. Infrastructure level alerting for your resources that are attached to your services. Dashboarding across services in general. So you can attach all these alerts to one consistent place that's controlled through IAC. Makes SRE happy, makes your team happy, makes anyone coming on board know exactly where to look for what they need. and SLIs and SLOs into automation. So let's start the conversation with business, with product, on how your service should actually be performing for a given feature. So any questions, comments? Yes, sir.
So one of the issues we ran into when we were trying to set up alerts using Terraform in Relic was the provider itself. So when you try to configure the provider using Relic API key,
Yeah.
we were like suggested to use like the personal API key rather than like a service accounts API key because that was throwing errors. So I want to see or hear from you guys like how you configure your provider.
As far as the provider win, the API key, it is a service level key at the scale of SRE, so only SRE has access to it. And given our fan out, how we're actually deploying our applications, it's put into Secrets Manager, and the secret is only pulled from the application itself. So engineers themselves don't have access to it, but when the Terraform runs, the runner actually pulls the key and makes the necessary alerts from IAC. Yes, sir. Over 50, probably closer to 75. Fun times, right?
What's your strategy for deploying also? Can you baseline the account? Are you running that, not run that until developers go? I didn't get it.
So it's going to be, as far as the rollout goes, the rollout system essentially started with the API keys, and then the actual aggregation of the Terraform module itself happens on a service-to-service deploy. So as the template owner or the service owner pulls in the latest changes from the template, it gets deployed. You create your own baseline audio alerts are set up from there. So it's kind of self-served now. Yes, sir.
Yeah, I'll piggyback off of that. So I was wondering where that Terraform code lives, if it's like in the app code repo, or like how do developers and teams interact with customizing their own alerts?
So we have our service level code, our application behavior, and our IAC split between repos, and there's a relationship between them. So the IAC repo is appropriately named after the service. So they're in tandem together. So when you actually need an IAC change, you're going to make your Terraform changes there. It's going to house all your infrastructure, all your NERCL alerts, all your new Relic alerts, and things like that.
I can expand on that a little bit too. So in the development of this module, we actually started with local modules. So it was actually code inside the individual repos while we were like fine tuning this thing. After it was deemed like good enough, the Cloud Ops team now kind of owns it in their kind of centralized repo and deployed through Terraform Cloud. So now teams can reference that module through Terraform Cloud instead of a local module. Yeah.
In Terraform Cloud, are you using one Terraform Cloud organization applying permission to use like workspace or state?
Correct.
Or
Yes. So there's one Chegg organization. Any other questions?
Sounds like you guys were able to just import different URL entities based on the observability that's support and just apply notifications to that. Right?
Yeah, so one of the required inputs, it's too far back, but one of the required inputs is the application name, and that's the unique key that we identify the entity to which we attach the policy, and then like we create all the extra resources on.
So one thing I've kind of struggled with is situations where you want to automatically generate entirely new entities so that they have their own, so that you can then automate the generation of their own dashboards or alerts and stuff. Do you guys ever try to do that, or?
I can answer first. So I did try, but not that specifically. I kind of ran into like a hard wall with Terraform because Terraform doesn't like that. It doesn't know whether, like, you're trying to do a conditional like data source read, right? It doesn't like to know, or it doesn't like to do conditionals. It needs to be there or not be there.
We gotta wrap up.
Yep. Last minute, any other questions? Oh, yes.
I have a question. It's kind of related to, it's different per organization, but how do using configuration as code as a repo, for me, it's really hard to move people away from like using the easy to use UI to saying, no, now you have to write your NERCL in JSON and put it here, and that's how you get your alert. How do you go through that transition, like in converting people? Or do you force them?
Do you want to answer that one?
Some would enforce since it's directly baked into the service template, but it's a conversation as well, stemming from the application team to SRE. Like you want consistency across both, and SRE doesn't need to like figure things out on their own. They want you to put guardrails in so you're not hurting yourself or your team. So you have a place to look back and say, you know, hey, this is here, this is where the change happened, so on and so forth.
That makes sense.
Thanks, guys.
Yeah. Thanks.
Hit us up if you got more questions.